Hey Bailey, here's kind of what we did today. Pardon me, I got a bit of a cold. So, started off on Desmos and we just graphed uh, each of these to see what happens. And what we're looking at is like how there's more than one of the same thing. Okay, right? There are two here and one of these. And what's the different things that happen, especially right at the um, intercepts, right? So this one would have an intercept at 1 and an intercept at -2 because that's where these would equal 0 and that's where it would cross. So just looking at those and saying, what's the different things that happen? Because something happens with this and something happens with that. And so then we got into what is called multiplicity. And it's the number of times the binomial occurs. And it changes what happens at the zeros. So what you'll see, if you go and try that, is that if we have it just something to the power of 1 or nothing, it just sort of crosses like a linear thing. It's either going to go up across or come down across, right? Depending on where the zeros are. If it's 1, that'll happen. If it's something to the power of 2, then you get like a little binomial thing, or a parabola happening, right? So it goes up, touches where the 0 would be, and then comes back down. It doesn't cross. And then if you get into multiplicity 3, like if there's the same factor 3 times, right? Like so x minus 2, x minus 2, x minus 2, what happens is it does like this shape. It kind of goes like that. It goes along for a bit and then comes back down and crosses. Okay. And we're going to use all of that so that we can sketch, these won't be really good graphs, this will be sketches of the polynomials in a way so that we have an idea of what they're doing. We won't be like really accurate drawings, but you can always check on Desmos to see how close you are. But yeah, we won't be really doing these as accurately. And these are kind of the information that we need to graph it. Those three kind of tie together. Then multiplicity, which we just talked about, and then we need to know about our x-intercepts, which kind of tie in with multiplicity, and then our y-intercept is good to find, and then sign analysis is something we haven't done yet. So I'm going to walk you through that in this example as well. Degree of a function. Remember, I'm going to use this as my example, x plus 1, x plus 2, and x minus 3. That's going to be my example for today. And so to get the degree, we just always multiply the first terms together. Right? So x times x times x is x cubed, so the degree is 3. Okay? And if there, so not much more I got to say about that. If the leading coefficient means, right, if there was hypothetically numbers in front, we're trying to see if it's positive or negative. So if it was like negative 2x plus 1 times 3x plus 4, x plus 1, different example, but we'll come back to that. We would multiply the first terms together again and get negative 2x times 3x times x, and you end up with negative 6x cubed. So I know it's degree 3. I know my leading coefficient is negative, and that's going to lead into telling me about the end behavior, right? Because if it's odd and it's positive or negative, if it's odd positive, it goes from quadrant 3 to quadrant 1, and if it's odd negative, it goes from quadrant 2 to quadrant 4. And then again, if it's even and it's positive or negative, it goes from 2 to 1, or it goes from 3 to 4. We've been talking about that in foundations as well as in pre-calculus. So that's, right, all these things kind of tie together. So back to our original example, which was this plus 2, x minus 3. We're kind of like saying it's where each factor equals 0. So you can think of it as x plus 1 equals 0. If I solve for x, x equals negative 1. So negative 1 goes in there, that makes that true. Right? Right. So at those points, that's where it's going to touch the x-axis, or you're going to intercept the x-axis, because that's where the 0 is, and so our function touches there. We need to know that for our sketch as well. Y-intercept, again, let's use our example. I should have just copied that. Okay, as we did with the degree, we're just going to multiply the last number of the second term. So plus 1 times plus 2 times negative 3 equals negative 6. So we'd expect there to be a y-intercept at negative 6. That's what we'd find if we graph this. Good. All right, so multiply the last numbers together. Excuse me. Okay, sign analysis. Maybe I'll pause this video here, or stop it, upload this, and I'll do the sign analysis separately. That way you don't have to watch 10 minutes of videos.